So, hello everyone, welcome to OneClass YouTube channel. My name is Devansh, and today we are going to go through a couple of popular problems in algebra. So, these questions are going to be at middle school or lower school level. Like, I don't think that you will find these questions at high school level, and especially at university level. But yeah, you can definitely find these questions at any aptitude test like GRE or LSAT or anything like that. So. And a little bit of background of myself. So I am in the final year of my graduation, and I'm doing my graduation in aerospace engineering. And if you need any tutoring help or if you need any one-to-one live sessions, then you can check the links in the description below. So, without wasting your time, let's just start with our lesson. Mm, yeah. So we have question number one. How to find the factorial of a negative number. So the thing is that the factorial, uh, uh, I'll just write factorial here. Again, please don't judge my handwriting because this is digital board and I don't have the practice of writing in on digital whiteboards. So yeah, so we need to find the factorial. So for example, let's say I have a number, let's say n number. N is the number. So to find the factorial of n, what we do is that we multiply n with n minus 1 with n minus 2, and it will go on until n minus n minus 1. So this is the formula for factorial. Now suppose if we plug in a negative number, so let's say the factorial of negative 1, then it will be negative 1 minus 1 will be, um, I'll just write minus 1 minus 2 and continue till minus 1 minus of minus 1 plus 1. So this will be minus 1 times minus 2 times minus 3, continue till minus 1. This will be 0, so this will be minus 1. And we can clearly see that this is not going to end. Like this kind of series, they never end, and that's why factorial of negative number and in fact factorial of 0 is not defined. So factorial of negative numbers does not exist. So if we go for the solution, then again in the given solution also it is mentioned that the factorial operator is only defined for positive numbers and the factorial of a negative number does not exist. So that is true, and I'll just say solution given here is correct. So solution given here is correct, and solution is correct. The answer is not given here. So we need to find the square root of 7. Okay. I'll just scroll this. Yep. Question number 2. We need to find square root of 7. Yeah, so for finding the square root of 7, we can clearly see that 7 is a prime number. So we cannot distribute this square root of 7 in terms of factors of prime numbers, and then we can just club the two terms together or club two similar terms together, and we can take it out of the square. So basically it is not possible to go with the simple radical method. So for this we are going to go for division method. So like one approach is very good and I like this kind of approach is that just calculate this root 7 in with your calculator. It is much more easier than calculating manually. And so let's say if you do not have a calculator and you are in a like you it is very much important for you to find the square root of 7. So what you can do is that we'll first identify the nearest perfect squares around this 7. So the perfect square greater than root 7 is square root of 9 and less than root 7 is square root of 4. This is nothing but 2 and this is nothing but 3. So I can so I can clearly see that my answer is going to be a number between 2 and 3. So what I will do, I will divide this 7 by 2 or the lowest number and I will get 3.5. Now I will take the average of this lowest number which from which I divided or by which I divided and the answer. So I'll write 3.5 plus 2 over 2. This will become 3.5 plus 2 over 2. This will become 2.75. Now what we'll do is that we'll just see that what is the square of 2.75. So the square of 2.75 is 7.56. It is 7.56, which is much more greater than 7. So we cannot end with 2.75. So what we'll do, we'll again divide 7 by the this number 2.75. 7 divided by 2.75, this will be 2.5454. Again I'll take the average of this number and this number, so this will be 2.5454 plus 2.75 over 2, and this will be plus 2.75 over 2, 2.6477. Now again I'll check the square of this, so I'll just square this term, and this is 7.010. So 2.6477 square is 7.010. Now you can end this problem here, and you can just write the square root of 7 is approximately equal to 2.64 until and unless in the question it is mentioned that the answer should be corrected till first decimal place. But if you want more accurate answer, so what we'll do, we'll just again repeat the same procedure. So I'll divide again 7 with this time with 2.6477. 7 divided by 2.6477, and this is 2.6438. 2.6438. Again I'll take the average of these two numbers, so it will be 2.6438 plus 2.6477 over 2, Hmm. I'll just again write this. So it will be 2.6438 plus 2.6477 over 2. This will be 2.6438 plus 2.6477 over 2. This will be 2.6457. I'll just check the square. So 2.6457 square is, oh, it is very much accurate. Like it is 7.000012345 zeros. So, and then 3795. So this answer is definitely acceptable. So you can write square root of 7 is. Now always remember that by this method, whatever answer we are finding, we will never ever going to write it like equal to. We are always going to say that the square root of answer which we find from this method is approximately equal to, because actually it is never going to be equal to um, square root of 7 is never ever going to be exactly equal to 2.6457. That's why always remember to just write this, draw this tile sign, so that it is approximately equal to. And yeah, this is the solution for this. And here the solution is not given, so I'll just write the answer here. Solution is not visible here, so answer is 2.64. Answer is approximately answer is approximately equal to 2.645. Oh, 2.6457. Yeah. And I'll just say that solution is incorrect because nothing is visible here. And we'll go for our question number 3. So I'll just add a page here. So which ordered pair is a solution of the equation? Let me just look at the solution. Okay. So the equation given here is 5x plus y equal to 23. What we'll do is that we'll just solve for y here. So I'll just add 5x on both the sides and it will become y equal to I'll just subtract 5x from both the sides. So it will be y 23 minus 5. Oh, it is minus 23 here basically. It will be minus 23 minus 5x. Now I'll just put the value of y equal to 0. Y equal to 0. 0 equal to minus 23 minus 5x. Then this will go here. It will become plus 23. So it will x will be minus of 23 over 5 and y will be 0. These are one set of coordinates. Okay, so what they have done, okay, so they have basically converted this equation in terms of slope method, or in terms like they have found the slope. I am not able to remember the exact name. It was slope intercept form of the equation. Yeah, So they have converted this equation of straight line in the form of slope intercept form. So we have the equation, it is y minus y1. I'll just wait. So we generally have this equation y minus y1 equal to m times x minus x1. And when we put x equal to 0, um, when we put x equal to 0, this is the normal equation, and y equal to mx plus c. Yeah, so this is the slope intercept form of the equation. So just by comparing these two equations, I can say that slope of this straight line is -5 and intercept is -23. Now let's see what they have done. So in general, the ordered pair, that is solution to this line, is x minus 5x minus 23. Okay, so we'll just draw this line first. I'll use a blue color right now, and this is the axis, and our given line will be something like this. It is going to be a straight line. And this point. So we can clearly see from this graph also that this line is um, like it is not a graph where the value of x is undefined. So for the every value of x, or every real value of x, the line is defined and the function is valid. So we can say that x comma y is going to be x comma minus 5x minus 23. Minus 5x minus 23 is nothing but this y only, and y is written here, and this is valid for x uh, in the range of real numbers. So it is defined everywhere, and that is pretty much all for this question. So in such kind of questions, we just draw the graph and we'll just see whether we have any discontinuity or whether we have any asymptote, and we'll just skip those parts where we have any discontinuous asymptote, and uh, um, excluding all the values. Whatever values where the function is defined is taken in the range of domain. So for here also I can say solution given here is correct. So correct solution. Good work. Solution is correct. So we have another question. This is question number 4. Yep, so this will be question number 4. So basically in these questions, if you are not able to see the minus sign, basically there is some error in the website. So minus sign, sometimes minus sign is printed, sometimes it is not, and therefore whenever there is a gap, it is nothing but a negative sign there. So we need to solve the inequality and graph the solution. the inequality is 8 minus 4 times minus 10n minus 3 is less than equal to 84. So for this case, we'll be having two conditions. So basically, when we have any value, let's say magnitude of x, then two values of the x is defined. So magnitude of x is, it will be positive x if x is greater than 0, and it is negative of x when x is less than 0. So for this one also, what I'll do is that I'll subtract 8 from both the sides first. So I will just write minus 8. I was using red pen, yeah. So minus 8 plus 8 minus 4 times magnitude of minus 10 minus 10n minus 3 less than equal to 84 and minus 8. So this and this will get cancelled, and this will be minus 10 n minus 3. 84 minus 8 will be 76. Now what I'll do is that I'll multiply both the sides. I'll divide both the sides with negative 4. So negative 4 and negative 4. But the thing is that in equality, I'll just cross check. Yeah. So in equality, whenever we multiply both the sides with a negative number, whenever we divide both the sides with a negative number, the sign of inequality changes. So in this case, earlier I just added. Okay, so in addition and subtraction, that thing is not valid. But in this case, I have divided both the sides with a negative number, so I have to change the equality sign. So it will be 10n minus 3 will be greater than equal to, and this will be 76 by 4. 76 by 4, 19. So this will be minus of 19. Now again we are going to use this, we are going to expand this magnitude in terms of this. So this magnitude would have two values. So when minus of 10n minus 3 is greater than 0, then I'll just go with the solution also. Yeah. So it will be, we'll just write this as it is. So it will be minus 10n minus 3 is greater than minus 19. I'll just add 3 on both these sides. So this will become minus 10n is greater than equal to 19 plus 3 will be 16. So this will be minus of 16. And then I'll again multiply minus 1 on both the sides. So this will be, and again my sign is going to change. So this will become n equal to, not n equal to basically, and now it will become n less than equal to minus 16 over minus 10 will be, I have to write this in fraction, 16 over 10, it will be 4, 2 5s are 2 8s are, so 8 over 5. So my n is less than equal to 8 over 5. Mm, just a minute. For minus 10 and minus 3 greater than 0, and when the term inside the magnitude is less than 0, we'll just write a minus sign here. 10n minus 3 greater than equal to minus 19. Yep. So now we are not going to change the inequality sign, because this negative sign is just for the modulus, and not we are not operating negative sign on both the sides. So it will become 10n plus 3 is greater than equal to minus 19. We'll just subtract 3 from both the sides, so it will become 10n greater than equal to minus 19 minus 3 will be minus 22. We'll divide both the sides with 10, and my n is greater than equal to this will be 2 11 times and 2 5 times, so minus 11 over 5 for minus 10n minus 3 less than 0. So they have written this is just a minute. 84, we had 84 here, this was 76, uh, 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 and we had to subtract 8 from both the sides. It was negative 84, I think. Oh god, this was negative 84. So I'll just make the corrections. So this will be negative, this will be negative of 4692, and this will become 92 by 4 23, so it will be minus of 23 minus, and minus minus will become plus. Okay, just a minute. Minus minus will become plus, so this will be 23. We'll operate this, so this will be 23. I'll just make the appropriate corrections, and then this 3 will come here, it will become plus 3, so this will be 26, and this will be positive, and then it will be 2.6. I'll just remove this, and I'll write 2.6, and n is less than equal to minus minus minus, yeah, so we had a minus sign also, so this is negative 2.6, and then here also we'll write 23. 23 was positive, and this was 23 minus 3, this will become 20, and this will be so this will become 23, and this will become 20, and this will become 10, so it will become 2. Let's just check this. So yeah, n is greater than equal to 2. Now we'll draw the number line for this. So this is going to be a number line, and let's say this is 0 1 2 3 4 5 -1, -2, -3, -4, -5, and so for here when n is greater than equal to 2, so it will be values from here till positive infinity, and when n is less than 2.6, so this will come somewhere here, and it will be till negative of infinity and positive infinity. So this is the graph, and yeah, finally we write this as solution will be, it will be minus infinity to minus 2.6 and union 2 to positive infinity. Mm, that is pretty much all I think for this question, and correct solution. Nice work. So in this way we find the we solve for the inequalities, and we draw the range in using number lines. I think you won't be able to see this question. I'll just zoom this. Yep. So Emio writes the multiplication sentence 50 into 30. First I should write the question number here. This is question number 5. So multiplication sentence 50 into 30 equal to 1500 as a first step in finding the quotient of 1590 on 3. She knows that 50 is part of the quotient. Then the then she writes a second multiplication sentence to find the other part of the quotient to add to 50. What is the product in the second multiplication sentence? Emio writes. So the first sentence is 50 into 30 is 1500. Now, as the first question, now she has to write this for 1590 also. So this is the first statement, and what we'll do, we'll just take the difference first. Minus 1500 will give me 90. Now in terms of 30, or let's just divide 90 with 30, we'll get 3. Okay, so 90 can be written as 30 into, just a minute, just a minute. Yep, so 90 can be written as 30 into 3, and the first statement was 50 into 30. Now what I'll do, I'll just combine both these statements. So 1590 is sum of 1500 plus 90. Now 1500 can be written as 50 into 30. 90 can be written as 30 into 3. If I just add these two, then it will become 1590. Um, let's just check the solution also. So have MU wants to find the quotient of calculation 1500 divided by 30 of ready she unite step me 50 into 30 equal to 150. So 1500 should be subtracted from the main divisor 1590, so will be, oh god, what kind of English is this? So 1590 minus 1500 is 90. Now 90 also divided by 30, so obviously 3 into 30 is 90 will be our second step. So 1590 is, now I can take 30 common from both the sides, so this will be 30 and this will become 50 plus 3. It will give me 50. 30 into 53 is 1590. So the her second statement should be something like this. And okay, so that is pretty much all for this question also. This was a very easy question. Not easy, kind of tricky, but yeah, we can do it. Until and unless we have proper English, we can do this question. So the solution given is correct. So correct solution. Good work. I'll first zoom this out. Yeah, this was question number 5. We'll go for question number 6. Again, I have to zoom this up a little bit so that you can see the question properly. Uh, this was question number 6, I guess. Yeah, I'll just add one more paper. Yeah. For this question, I'll now start with black color. 6. Oh god. So question number 6 is solve using logarithmic properties. Detail, please solve. Okay, so we need to solve this using properties of log. W square. Okay. Now what I will do, while solving this, I'll just mention the properties which I have used. So first I will divide both the sides with 20. So this will become minus 3 over 20. And this will become log base 10 of 2 over minus w square plus y. Is this y? This is 4, I think. Okay, so there is a printing mistake in this question. This should be 4. That's why I was wondering why is this given like that. Now what we'll do, we'll use the property of log. So log base a of b equal to c. Then when we take the antilog on both the sides, then we'll get b equal to a power c. So in the same way, I can take the antilog here. So what I should do, this will become 2 over minus w square plus 4 equal to 10 power this whole term, which is minus 3 over 20. Now we can write this 3 over 20, like basically we have to go for some minor manipulations here. So what we'll do, we can write this 10 power minus 3 over 20, sorry, minus 3 over 20 as this will be 1 over 17 over 20. I think they have minus 3 over 20, 17 minus, okay, 17 minus 20, okay. So they have done 10 power minus 3 can be written as 17 minus 20 over 20, and this can be written as um, 17 over 20 minus 1, and as the base is same, so we can split this and it will become 17 over 20 into 10 power minus 1, which will become 10 power 17 over 20 over 10. So I'll just substitute this in this equation. So I'll get 2 over minus w square plus 4 is 10 power 17 over 20 over 10. Now I'll just do the cross multiplication for both the sides. So 2 with 10 and this term with this term. So it will become 2 into 10 equal to minus w square plus 4, 10 power 17 over 20, and this will become 20. And I'll just write this equation. So this will be let's say I'll just write this. I won't be skipping any steps. Minus w square 10 power 17 over 20 plus 4 into 10 power 17 over 20, and I'll just take all these terms on this side so that I'll get my w square in positive. This will become w square uh, into 10 power, obviously. So this, and then it will be I'll just check that, okay, minus 4 into 10 power 17 over 20, and this will be plus 20, I guess. So this will be equal to minus 20. Okay, they have taken this on the other side. Now in this equation, let's say that a is 10 power 17 over 20, b is 0, and c is minus 4 into 10 power 17 over 20. So we can oh, okay. Basically I was right in this step. We'll just add 20 here and it will be equal to 0. So let's just say that this is a quadratic equation and the middle term is equal to 0, and this one is plus 20. Now we can clearly say that w will be minus b plus minus underscore under root of 4 b square minus 4ac over 2a. So w will be, b is 0, so it will become plus minus square root of, and again b is 0, so this will be minus 4 into a is 10 power 17 by 20, and c is minus 4 into 10 power 17 over 20 plus 20, so and over 2a, yeah, so 10 power 17 over 20. I'll write w as I'll just multiply this, so this will be square, and um, this will become, it is better to write in the power of 1 by 2, so this will be plus minus 4 into 10 power 17 by 20, 1 by 2, minus 4 into 10 power 17 by 20 plus 20, 1 by 2, 2 into 10 power 17 by 20, and then mm, 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 just a minute. Yep, so where was I? I was, just a minute. Yeah, so I'll take the square root of negative 4 and this will become positive 2, so I can just cancel both of them, so I'll get w as, and then what I will do, this will be 17 over um, um, 2 times, so this power will be multiplied with 17 over 2, so this will become 17 over 40, and then it will become minus 17 over 20 minus, so I can just write this as plus minus 2 into 2 power 17 over, mm, I'll just take the reference also from here. Yep, so it will be 2, this will be 40 times 5 power 17 over 40, and this will be 10 power 17 over 20, and this will become, um, they have taken minus sign common, okay, so this will become 5, okay, yeah, so they have cancelled with this minus sign, okay, and this will be 1 by 2, and w will be, I'll just write the final answer because this question is, um, yeah, there are some very basic like manipulations, so it is acceptable. The thing is that I cannot read, okay, so it is 23 over 40 times square root of 10, 17 over 20 minus 5 over 5, and yeah, definitely plus minus, so for one value will be of plus and one value will be of minus, and this manipulation was really hectic. I'll just say that the solution was correct, is correct. Good work. I'm going to zoom this out. Oh god. Okay, so now we'll have question number 7. So write a vector equation for a vector for each arrangement of vectors. For example, if adding b and c gives a vector, then write a vector equal to b plus c vector. Each answer you give should start with a equal to. Okay, so the thing is that in this problem, we'll just take the vector diagram and we'll go clockwise. So if the tail comes first, then the vector is going to be positive. If the head comes first, the vector will be negative. So I'll just start with the first example. So we have this, then we have this vector C, and let's say this is another vector. So this was B and this is A. So we'll start from here and we'll go clockwise. So we can clearly see that B tail is coming first, so B will be positive. Then we'll go clockwise, and for A, head is coming first, so A will be written as negative. And then again for C, head is coming first, so C will also be negative. This implies I'll just add A on both the sides, so B minus C is A. Let's just check with the solution. So B minus C equal to A. Now we'll go for the second figure. It is like this. And then a vector in this direction and a vector joining both of them, and this will be A, this will be C, and this will be B. Again we'll go clockwise, so I'll just start from here. So tail is coming first, A is positive, C will be positive, tail is coming first, but for the B, head is coming first, so B will be negative. And to write this in terms of A, we'll take C and B on the other side, so we'll just add B and we'll subtract C from both the sides. This will become minus C plus B. So let's check for B also. Yep. So minus C plus B. Okay. We should definitely write the vector signs here. So I'll go for the C figure. For the C1, I have this straight vector here, A, and then I have one vector like this, C, one vector like this, B, and now I will, let's start from this point. So head is coming first, B is positive, A will be negative. Sorry, tail is coming first, B will be positive, head is coming first, A will be negative, and then again C will be negative. And for writing in terms of A, we'll just take A on the other side. This will become B vector minus C vector equal to A vector. Let's just check for C, A is minus C plus B, correct? For D, so for D it is, one is like this, one is like this, I just want to erase this. So one is like this, and then another is like this, I think, and then one is like this, and other one is something like this. Yep. So this one is E, this is B, this one is D, this one is A, this one is C. So again, let's start from this point. So tail is coming first, A is positive, head is coming first, E will be negative. Then for B, tail is coming first, B is positive. Then for D, again, D is positive, and for C, head is coming first, so it will be negative. And I'll just take all these vectors on this side, so their sign will be changed. Their sign is going to be changed. So it will be, E will become positive minus B minus D, and this will be plus C. Let's just do for C also, for E also, and we'll just check the answer afterwards. And this one is A, C, B. Let's start from this point. So C is positive, then B is negative, then A is negative. I'll take A on this side, so that I'll get equal to A vector. So again, the solution clockwise or clockwise, and for D we have to plus E minus B minus E plus C. Okay, correct. And for last one, C minus B. Yeah. So again, solution given here is correct. So correct solution given here. And I think that this is going to be our last question for now, for day. Mm, question number 8. So we have x square plus 5x plus 6, and we need to solve this quadratic equation using the formula. Okay, so x square plus 5x plus 6 equal to 0, and we need to use quadratic formula. Now what, I'll just use blue color. So suppose, let's say we have an equation a x square plus bx plus c equal to 0. Let's say this is a general quadratic equation. Then to find the value of x using the formula, there is a direct formula. Okay, so it is minus b plus minus square root of b square minus 4ac over 2a. So I'll just use red now. So in this equation we can see that a is uh, 1, b is 5 because this x is multiplied with 1, and b is 5 and c is 6. So I can write x equal to minus 5 plus minus square root of b square means 5 square minus 4 into 1 into 6 over 2 into a. So we are going to get two values from this formula, and x is minus 5 plus minus square root, this will be 25 minus 4 6 are 24 over 2. So this will become minus 5 plus minus, this will be square root of 1, which is nothing but 1 only, and 2. So first case will take the plus sign here, and for second we'll take this negative sign. So let's say x1 is minus 5 plus 1 over 2. This is minus 4 over 2 will be minus 2, and the second root is minus 5 minus 1 over 2. Just a minute, I think, yeah. So minus 5 minus 1 over 2, which is, this is minus 6, and this will be minus 3. So let's just check the solution also given here. So minus 3 and minus 2. So the solution is x is minus 2 and minus 3. And this is the solution given here. So I'll just write correct solution. Good work. So basically in this way we find the solution of a quadratic equation. We just find the constants a, b, c, and then we use this formula, and it is a very, like, seriously, it is a very uh, brilliant kind of formula, or I can just say that it is one of the most amazing formulas, because in daily life, like I'm an engineer, so in our daily workload we encounter with many quadratic equations, and always, like always, I don't go for other methods. I always use this formula to find the solution of any quadratic equation. So I'll just say that solution is correct here, and I think that that is pretty much all. So yeah, if you like this session, then please do hit the like button and do subscribe to our channel also. And if you need any tutoring help, or if you need any one-to-one live sessions, then you can check the links in the description below. And please do hit the bell icon so that you will always be updated with our live streams. So at last, this was Devansh, senior tutor at OneClass, and I hope to see you soon in my next stream. So till then, bye.